CUA 9 retake. Let go. Calculate the length of A, B. So we see here that we have two sides. No angles are labeled. We have no way of knowing what they are, but we can use Pythagorean theorem. Sorry about that. All right, so this is side C. That's the hypotenuse. This would be side A. This could be side B. So the Pythagorean theorem is a squared plus b squared equals c squared. But as I told you before, you could use one of the shortcuts. Since c is missing, we will use the c equals shortcut, which means we'll take the square root of a squared plus b squared. So let's get into it. All right, so we got, what is that, 144 plus 64. And if we add those two together, that'll be, I think, 208. Excuse me, and we need to simplify 208. So I don't know. Let me figure out how to simplify that. So I could break it down into its prime factors. You know what? I'll just do it that way because I feel like that's the way most people remember how to do this. So we're going to get the prime factors. So that's 2 to the 4th times 13. So 2 times 2 times 2 times 2 times 13. And then we're just going to take out the doubles. So that's a double. Oh, shucks. Okay, there we go. That's a double. And that's a double. And what's left is 13. So that'll be 4 square root of 13. I'll just put it down here. 4 square root of 13. If you are on level, what you can do is type this into your calculator and it will just give you a decimal answer. So that'll be the square root of, what was it, 12 squared plus 8 squared. That'll be 14.4. Right, so there's your answer as a decimal, and there's your answer as a radical. Go ahead and try number 2. Number 3. Jackie is standing 83 meters from the base of the Empire State Building. If the building is 380 meters high, find the angle of elevation. Okay, now I done told you, when you're doing angle of elevation, this is the triangle you need to use. Your angle of elevation will always go there, and that's what we're trying to figure out, so never mind. It says that Jackie, hey girl, it's a little ponytail. Whoop. All right, so Jackie is standing 83 meters from the base. Oh, this is not drawn to scale. My bad. It's all good. 380 meters high is the height of the building. Oh, sorry, the building is 380 meters high. So that's how we got it labeled. Now, once you got the triangle set up, label, label, label. Label theta, which we already did. Once you figure out theta, it's across from the opposite side. Your hypotenuse is always going to be across from the right angle, and then adjacent will be the one that doesn't have an arrow pointing to it. Now, if you can see here, the hypotenuse is blank, so we don't need it. What we do need is opposite and adjacent. So if you use SOHCAHTOA, there we go. If you use SOHCAHTOA, the only one that has opposite and adjacent, so O and A, is this one right here. The T stands for tangent, theta. The O stands for opposite. The A stands for adjacent. Now we're going to set it up and solve. So tangent theta, we don't know what theta is, so you can put an X there, or you can leave it as the Greek letter theta. It don't matter. A variable is a variable. Opposite was 380. Adjacent was 83. Cool. Now since X, or since the variable is not at the top, it's not at the bottom, but the angle is what's missing, we're going to have to use the inverse. Oops, that's not enough space. Sorry, Jackie girl, I'll have to move you, honey. So that's going to be tangent inverse, and then put the fraction on this side, and that'll give us theta. All right, so we get 77.68. I'll just put 77.7 degrees is theta. All right, go ahead and try number 4. Number 5. What is the length of the side labeled with X in the diagram below? So X is right there. Okay. All right. So it's looking like Pythagorean theorem. So I'm going to start with the triangle that has the most numbers on it. This triangle only has one number. No angles are labeled, so we can't use trig or special right triangle rules. This triangle has 2 numbers, so we can use Pythagorean theorem to find this third side. I'm going to call that third side y because I can. All right, so with this first one, this would be the hypotenuse. So I'm gonna use a different color. This would be the hypotenuse. So if you want to call that C, that's fine. Just for the sake of like knowing what to do. All right, so we're using this. A is missing. So we're gonna use our shortcut, our shortcut for A, which is the square root of C squared minus B squared. So that's gonna be, I'm gonna replace A with Y, and then C is 25. So that'll be 25 squared minus 16 squared. So that'll give us 369 under the radical. Now, if you are on level, if you're not in honors, then just do the whole square root, like do the square root of 369, or you could just go straight from here, put that in your calculator, get the decimal, and go from there. I'm going to leave it like this. So that's why. I'm not even going to simplify it because there's no need. We're going to use it again anyway. All right, so now we're going to have to figure out x. So we figured out y. Put a little check, boom. Now we got to figure out x. So for this triangle, this is going to be C. So I'm going to get rid of these so I don't get confused. That's our new hypotenuse, right? This could be called A if we wanted to. This could be called B if we wanted to. Doesn't really matter with those. So since A is missing, we're going to repeat that same shortcut. Okay? So instead of putting in A, now we're going to put in X. And C is 22. B is, what was it again? The square root of 369 squared. All right. So we got, I'm just going to put this in the calculator without the radical. Okay. Oh, just so you know, sorry. The square root of 369 squared is just 369. So that's why when I put it in, I put 22 squared minus 369 because it's just going to give us 360. You know, let me do the whole thing because I feel like y'all are like, wait. There. All right, so see, we still get 115. So that's going to be the square root of 115. And we're going to have to simplify that. So let's figure out the factors of 115. That's 23. Okay, we can't do nothing else with that because 5 is prime, 23 is prime. So that's it. We are done. All right, go ahead and try number 6. Number 7. What is the measure of angle A rounded to the nearest degree? So I'm going to put theta right there, which means this is my opposite side. This is my hypotenuse, of course. And this would be the adjacent side. Opposite is blank. Leave it alone. So if we use SOHCAHTOA, We see that we have hypotenuse, which is H, adjacent, which is A. This is the only one with an H and an A. So we're going to use cosine theta. That's what the C stands for. The A is for adjacent. The H is for hypotenuse. And now we're going to plug in what we know. Theta is unknown. That's what we're trying to figure out. Adjacent is 11. Hypotenuse is 61. Since the angle is what's missing, we have to use the inverse. All right, so that'll give us 79.6 degrees. Go ahead and try number 8. Now 8 is asking for the length of BC. So that's x. So you're going to want to use Pythagorean theorem. This one's a little different. Number 9. One end of a 12-foot ladder is 5 feet from the base of the wall. How high on the wall does the top of the ladder touch? You know what? I'm just going to draw. Okay, struggles. All right, so this is the wall. I probably shouldn't call it a wall because I'm going to have to put numbers there. This is the wall. Look at me, I'm a brick wall. That looks like a ladder. Okay, I'm not doing really well with this. That's a wall. All right, this is the ladder. This excellent drawing skills that I have. You're welcome. Okay. And it says that it's a 12-foot ladder. So the ladder's 12 feet. And how high on the wall does the top of the ladder reach? Oh, 5 feet, my bad. 5 feet from the base of the wall. And then how high on the wall? So that means the height. That's what we're trying to figure out. All right, so this is just regular Pythagorean theorem. We know that's RC. This could be A. This could be B. So since A is missing, we're going to use this shortcut formula. And let's plug in what we know. A, I called X, so you can leave it as A if you want to. It's not a big deal. We know C is 12, B is 5. Oh, to the nearest hundredth, my bad. So I'm going to actually do the square root because that's what it asked for. All right, 10.91. And there you go. Easy peasy. Number 10. And number 11. A rescue helicopter pilot spots a stranded fishing boat. The angle of depression is 35 degrees, and the helicopter's altitude is 1,800 feet. So first of all, it says angle of depression. So I'm going to draw my depression triangle. That sounds like it's a triangle for when you're depressed, but that's not what it means. Sorry. The angle of depression, excuse me, goes right there. And it told us that it's 35 degrees. The altitude is just the height. So we're going to put that where the height goes. And then what's the helicopter's approximate distance from the stranded boat? That's going to go there. All right, let's do it. So label, label, label. We already know theta is right there. This would be our opposite side. And of course, this is the hypotenuse. The adjacent side is blank. All right, so if we use SOHCAHTOA, then I see that we have opposite, so O, and hypotenuse, H. So we're going to use sine. S is for sine theta, O is for opposite, H is for hypotenuse. Sine of 35, because theta is 35, equals opposite over hypotenuse. All right, now we're solving for x. X is in the fraction. So we have to get x by itself. Yellow. So to do that, we need to multiply both sides by the denominator. Boom. So now we have x times sine 35 equals 1800. Still need to get x by itself, so we're going to have to divide both sides by sine 35. So x is going to equal, let's see. All right, it said to round to the nearest whole number, so I rounded to the nearest whole number. That just means no decimals, round up if it's 5 or more after the decimal. All right, Zach is standing at the top. Oh, sorry, try number 12. All right, number 13, what's the value of x? So since this is clearly a 44, okay, maybe not clearly, but this is a 45, 45, 90, we could tell because it's isosceles. If it's isosceles and right, that means it's automatically, no matter what, 45, 45, 90, no matter what. If you listened the first time, then you would have known that. All right, so this is a leg. This is a leg. There is no short leg, long leg, sweetie. It's just leg and leg because they equal. And then, of course, this is the hypotenuse. Okay. So we're going to get from leg to hypotenuse, we have to multiply by the square root of 2. Like so, like that. So we're going to take this, 16 square root of 2, because that's what the leg length is, and we're going to multiply it by the square root of 2, and that'll give us our answer. So 16 times the square root of 4, which equals 16. Square root of 4 is just 2. So that's 32. All done. Go ahead and try 14. Number 15, given the right triangle below, determine the ratio for tangent B. So B is theta. Since we're doing tangent, oh, hold on, let me write it down, child. All right, so we're doing tangent theta equals opposite over adjacent. That's what the letters stand for. So that'll be tangent theta, we don't know the angle, equals opposite, which is 9. That's a 9, not an A. Over adjacent, which is 12. I'm sorry, I did not label. Let me not get ahead of myself. And then, of course, the 12 would be adjacent. Okay, so there you go. We need to simplify this fraction because it's asking for the ratio. It's not asking for the angle. It's asking for the ratio. So if we simplify 9 over 12, that'll equal 3 over 4. Okay, just divide by 3. You can tell because 9 and 12 are both multiples of 3. Go ahead and try number 16. And number 17. Given the triangle below, calculate the length of the side labeled with x. Okay. Now we got a 30, 60, 90 triangle. This is the special right triangle. Yes, you could use trig, but I'm not going to do that because it takes longer, and I taught you these rules, so you should have them in your notes. All right, so why did I do that? I have no idea why I did that. Sorry. This is the short leg, which is across from 30. The short leg is always going to be across from 30. This is the long leg, which is always across from the 60. And then across from the 90 is always the hypotenuse. All right, cool. So we need to figure out x. When you know the short leg, which we do, and you're trying to figure out the long leg, which we are, you're just going to multiply by the square root of 3. So the short leg is 5, and then 5 times square root of 3 is just 5 times square root of 3. You can't simplify it anymore. Number 18, give it a shot. Number 19. So we need to determine the length of x. Okay, trig. I can always tell trig because there's an angle, and then there's like a side, and they're asking you for like another side. All right, let's label what we do know. We know this is the hypotenuse. Opposite is over here, but it's blank, so don't worry about it. This is adjacent, so that would be sine. Why did I say sine? Honey, that's cosine. This is, see, I'm getting on y'all. Let me write it down, honey, if I mess up again. My bad. This is definitely chi or cosine. Okay. So that would be adjacent over hypotenuse. I should know from the song. Cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse tangent. Opposite adjacent tangent. All right. So we're here. We need to get x by itself. So since we're solving an equation with a fraction, multiply both sides by the denominator. You can always do that, sweetie. Like always. All right, let's type that in the calculator. This will be a good time to say if you have a calculator and you're not getting the same answers as me, you want to make sure you're in degree mode in your calculator. All right, you can ask somebody next to you because I guarantee your teacher has told you multiple times how to change it to degree mode, and either you were maybe just absent every single day or you just didn't pay attention. So ask your neighbor how to do that if you need help doing that. All right, it said to round to the hundreds place. The hundreds place is two places after the decimal, two places to the right of the decimal. All right, go ahead and try number 20. All right, number 21. Number 21, the street sign below is in the shape of an equilateral triangle. Nope, go to bed. All right, with a side length of 24 inches. Well, shucks, I didn't even tell you what it's supposed to be. So you're trying to figure out the height. Yuck, can't see that. All right, you're trying to figure out the height. So let's go ahead and figure out the height. So first thing is, if this is an equilateral triangle, that means all the sides are 24. That also means that the height should cut this side in half, and half of 24 is 12. So with that in mind, that's what we're going to be dealing with. All right, so this is obviously our right angle. You can just use Pythagorean theorem. I wouldn't overthink it. You could do different things because if this is equilateral, that means this is 60 degrees. And if that's 60, that means that's 30 because that's half, right? Because that would be 30, that would be 30. So you could use 30, 60, 90 rules if you wanted to. Oh, wait, we probably should. No, we could do either way. So if I use 30, 60, 90 rules, then I would just be like, oh, this is the short leg, this is the hypotenuse, this is the long leg. So I would use the short leg, multiply that by the square root of 3 to get the long leg. So that would just be 12 square root of 3. So you could do that. But if you didn't know that, you could just use Pythagorean theorem. And if you use Pythagorean theorem, you would be trying to find A or B. So to figure out x, you would just do the square root of 24 squared minus 12 squared. So let's figure that out. No radical. I'm just going to do what's underneath the radical. That'll be 432. And then we have to simplify 432. And let's see if I divide by, let me just do it the way I used to doing it. All right, 2 to the 4th, 3 to the 3rd. And then take out the doubles. And a 3 is left. If we multiply 2 times 2 times 3, that'll give us 12, square root of 3. So you get the same answer either way. Now, some of y'all might be thinking, oh, let me do it the 30, 60, 90 way because it's faster. And I'm like, well, yeah, of course it's faster. That's why I gave it to you. But most of y'all didn't remember it. So just do what you remember, okay? All that shade throwing to say, if you know Pythagorean theorem, just use Pythagorean theorem. If you can use trig, just use trig because I feel like people remember those better than the 30, 60, 90 rules. Go ahead and try number 22. 23. All right, we got a 20-foot tall building with a 40-foot long shadow. Oh, you just gonna play me like that? Thank you. Okay, so 20-foot tall building, 40-foot long shadow, and we're trying to figure out what angle meet the ground. So I just want to use the angle that's by the ground, in case you're wondering why I put it down there and not up here, because that's not the ground. Okay, so we've got opposite and adjacent, so this is going to be a tangent problem. Again, that's opposite, this is adjacent, and you should know from CUA that opposite and adjacent is tangent. So that's going to be tangent theta equals opposite over adjacent. Tangent theta, because theta is yet unknown, equals 20 over 40. And if we're going to do if we're looking for the angle, we're going to have to do the inverse tangent. And just throwing this out there, you could always simplify this fraction to 1/2. I don't know why I felt the need to say that. It's unnecessary. Let me be quiet. All right. Tangent inverse of 20 over 40 is 26.57. Oh, just kidding. To the nearest whole number. What did I say? 26.5. So that's 27. Let me double back because I don't trust myself. Okay, cool. They're 27 degrees. Go ahead and try number 24. Number 25. where can the perpendicular bisector of the sides of an obtuse triangle intersect? My suggestion to you would be to draw an obtuse triangle. I'm not going to make it isosceles because I want us to see the difference here. And this is perpendicular bisector, so oof, I'm going to try my best, child, to find the middle. Oh, I'm doing my best. I forgot how to pull up the ruler on Notability. I always do it by accident, but I can never do it when I need it. So I'm going to do my best to sketch. I could just use the corner of a sticky note. Oh, I have a sticky note right here. All right, cool. Let's do that. Here. These are not as close as I would have liked, but that's okay. All right. There's that. Oh, this is not long enough. Let's continue that line. Oh, crap. Too long. Too much. I went too far. Okay. And so now we're going to, hold on, let me get my sticky note so I can make a right angle with this bottom line here. Okay, cool. And then I'll just extend it like this. What you do? Try that again. All right, there we go. I mean, you can already see where these lines intersect, but for the sake of continuing what I started, I shall persist. This looks fantastic. Oh, shucky ducky. Actually, that might work in my favor. Okay. Oh, wow. Can we talk about how this actually came together at one point? What? Come on, guesstimation skills. Pat myself on the back. So this should be perpendicular. This should be perpendicular. And it is hopefully bisecting so that those two sides should be the same. Those two sides should be the same. And these two sides should be the same. You know what I'm saying? Like this side should equal this side. This side should equal this side. This side should equal this side. So that's what we mean by bisector. Anyway, long story long. these intersect outside the triangle. Meet, 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 meet. Go ahead and try number 26. 27. Point P is equal distance from the blank of triangle ABC. So point P, let's identify what kind of point it is, and then we'll take it from there. So these are all angle bisectors. Oops. So angle bisectors. I'm walking you through my process. Intersect at the in-center. My handwriting isn't great. Stay with me though. I promise we're going somewhere with this. All right, so that means P is the in-center. Why is this important, Miss E? Stay with me. I got you. All right, so since this is the in-center, that means, and this was in your notes, boo. This is in your angle bisector in-center notes. So if you not believing me, just flip through your notebook right now and find it because it's in there. Anyway, so since this is the in-center, one of the properties of in-centers is that, to make it nice, is that it's equal distance, same distance, to all three sides of the triangle. There you go. That's it. All right, go ahead and try number 28. And look at your notes. Look at your notes. I promise, stuff be in there. Y'all just don't read. Peace.